Hi guys, in this video we're going to look at two hypothesis tests, two examples of those, and these two hypothesis tests are going to be applied to a binomial distribution. First thing I'm going to do is just read the question out, and then we're going to think about the information that you're given in the question and how we're going to use that to apply this hypothesis test. So the question says the probability that a student at a certain school passes the stats component is 0.8. A new teacher is appointed and takes the next group. Out of a group of 10 students, only 6 students now pass. Should the head of maths be concerned? And this is going to be using a 5% significance level. The first thing we need to do from this is think about what we're actually testing for. So if we look at this, it's telling us that should the head of maths be concerned, we need to use that bit of information. Now, as I said, this is going to be using a binomial distribution. And there's a couple of key things in this question that we can pick out that shows us that we can use a binomial distribution for this. To start off with, what I'm going to do is I'm going to use the variable x to represent the random variable in this. So we're going to say that x can be distributed binomially, and if it can be distributed binomially, we'll write it in this way, where the two numbers inside the bracket here represent n, the number of trials, and p, the probability of success. So here the number of trials will be 10 because we're saying, or we're looking at a group of 10 students. P, our probability of success, is going to be 0.8 because that is the probability that a certain school passes the stats component. So we're going to write it in this way, and we're going to say that this is where x represents the number of students that pass. So this is just setting up our hypothesis test. The next thing we're going to do is we're going to consider our hypotheses. Now, our first hypothesis is called our null hypothesis. And for our null hypothesis, that's always going to be an equality. And it will always be relating a probability. And in this case here, that is going to be the probability is 0.8, because at the moment that is the probability that we were given, and we're going to look and test and see if that is going to change in any way. That is going to be our alternate hypothesis. Now, if we're looking at our alternate hypothesis here, this is going to be how the probability is going to change in some way. The question says, should the head of maths be concerned? If we're testing to see whether the head of maths is going to be concerned, we're looking to see whether that probability is now less than 0.8. We're not interested to see whether that's increased, because if it is increased, that's obviously good, but it means that the head of maths wouldn't be concerned. We're only interested as to whether that's going to be less than 0.8. Now, there's a couple of bits of information we need to now pick out from our question that's going to help us in conducting this hypothesis test. One of those bits of information is going to be our test statistic, and we were given this in the question here. So it says only 6 students have now passed this test. That is our test statistic. I'm just going to write that down here. So our test statistic is going to be that x is equal to 6. Now, to be able to conduct our hypothesis test, we need to calculate something called our p-value. And using the work that we've done earlier on this, we should hopefully have an understanding that our p-value is the probability that x takes the value of the test statistic or is more extreme than that. Now, in this case, our p-value would therefore be the probability that x is less than or equal to 6. We need to calculate this probability here. Now, I think one of the hardest parts of this is just understanding why we're choosing to look at less than or equal to 6 as opposed to greater than or equal to 6. And one of the key ways of knowing that and why we're looking at less than, firstly, we're always going to be looking in the same direction as our alternate hypothesis. So that's less than, so this is also going to be less than or equal to. And the other thing to consider is we can work out the expected number of people to pass this test using our probability and using our value of n. Here, if I was going to times n and p together, then in this case here, that would give me 0.8 times by 10, which is going to be 8. So 8 would be our expected number of people to pass. Now here we've got a value of 6. 6 is less than 8, and it's less than the most common or the expected number. So for that reason, that's why we're looking at less than or equal to 6. We can use our calculator here to find out what that probability is going to be. So if we go into our distributions, so into the menu and into our distributions, if we go to our binomial distribution and we're going to go to the cumulative function, we're going to use our variable because we're only looking at one value, and we're looking at for when it is less than or equal to 6. So I'm going to put in a value of 6 for x, n is going to be 10, and our probability of success is 0.8. And the probability that has given us there is 0.12. 1 to 3 significant figures. That's our p-value. And we need to use our p-value and compare that with our significance level to decide on whether we accept or reject our null hypothesis. So in this case here, we have a p-value of 0.121. Our significance level is something that we were given in the question, and we were told that that's 5%. 5% as a decimal is obviously 0.05, and we can see that actually our p-value here is greater than our significance level. Because of that, if our p-value is greater than our significance level, we would always choose to accept our null hypothesis. And we would choose to accept our null hypothesis because this is showing there's not enough evidence for us to reject that. If we're accepting our null hypothesis here, we're accepting the fact that actually the probability is still 0.8. There wasn't enough evidence in this example here to prove that the probability had decreased. Now obviously if we'd have used or found or been given a lower number than 6, our probability here would have also been lower. And if that probability was less than 0.05, then we would have rejected our null hypothesis. And we'll look at an example where we'll do that in a second. Just to finish this question off, now we've accepted our null hypothesis, we do just need to give a conclusion. And the conclusion will always comment on our alternate hypothesis. Our alternate hypothesis is that whether our head of mass should be concerned. So because we've chosen to accept our null hypothesis, we would then say that there is insufficient evidence to suggest that the head of maths should be concerned. And that's just our concluding statement there. Okay, so in that first example we chose to accept, or we had to accept our null hypothesis, and then we found that concluding statement. I'm going to show you a second example now, and in this example now, we are then hopefully going to be given one where we're looking at rejecting our null hypothesis, and we'll see what we do in that instance. So on our second example, we're going to look at this one here. We'll do this in a similar way, so I'll read the question out and then go through this in detail. For this question it says, a student takes a multiple choice test. There are 20 questions with 4 possible answers. Unfortunately, the student has attended very few lessons, so has to guess. The student gets 10 questions correct. The student claims to be an inspired guesser. Is this true? And this is at a 5% significance level. So before we do anything here, I'm going to write down and show that this is or can be represented using a binomial distribution. And we're going to bring in the letter x again to represent our random variable. So where x is distributed binomially, here the total number of trials is going to be 20 because there are 20 questions in total. Now we're not given the probability in this question, but what we are told is that there are 4 possible answers, and we are told that the student is going to be guessing. So the probability of choosing the correct answer here will be 0.25. And we're then going to explain that x represents the number of correct answers. Now we're going to think about our hypotheses. So our first hypothesis is our null hypothesis, and that's where the probability is equal to something. Here it's the probability is going to be 0.25 because if we're guessing, then that is the probability of choosing the correct answer. For our alternate hypothesis here, we're testing to see whether the student is an inspired guesser. If the student is an inspired guesser, that suggests that the probability is going to be greater than 0.25. They're more likely than that to choose the correct answer. So here we're going to be looking at testing to see whether the probability is actually greater than 0.25. Looking at the question, we're also going to state our test statistic. So here, our test statistic in the question is going to be the number of answers the student got correct in this experiment. So the student gets 10 questions correct. So here we're testing this using x is equal to 10. Now this is where we come to think about our p-value. And obviously our p-value is our probability, and it's the probability that x takes that value or is more extreme than this. Now this is slightly different, and this is different because we are testing to see whether the probability is greater than 0.25. Obviously here, to find our expected number, if we wanted to do this again, we could do n times by p. So we could do 20 times by 0.25, and that would give us an answer of 5. So our expected number of correct answers would be 5. Now we're actually testing to see whether this is greater than that, and we're using a value of x is equal to 10. Because of that, to find our p-value, we are going to be finding the probability that x is greater than or equal to 10. So to take that p-value, to find the p-value, we look at whether x, or the probability that x takes that test statistic and is more extreme than that. Now, if we're looking at calculating this on our calculator using the binomial distribution, because this is a cumulative function, we cannot find out the probability is greater than something. So in this case here, we need to think about how we're going to use an inequality that involves a less than to be able to find out this. And we would do so by subtracting the probability that x is less than or equal to 9 from 1 to give us the probability that x is greater than or equal to 10. So I'm going to do that on my calculator now. So we're already on the binomial distribution from last time. Now my value of x is going to be 9. My value of n, number of trials, is going to be 20, and the probability of success is 0.25. Calculating that will give me the probability that x is less than or equal to 9. Here, I want to do 1, take away that answer. So my calculator, remember that. If I go back into the calculation here, I'm going to do 1, take away my answer, to give me a value of 0.0139 to 3 significant figures. So that's my p-value. The next stage of this is to compare my p-value with the significance level. So my p-value is 0.0139. My significance level in this test is still 5%, so it's still 0.05. Now in this case here, the p-value is less than the significance level. So it's different to the question before. Now this is really important. This will always stay the same for any hypothesis test. If our p-value is less than our significance level, that shows that there is enough evidence to reject our null hypothesis. Okay, that probability was that small that we need to reject our null hypothesis. Okay, and obviously the further this value moves from our expected value of 5, the lower this probability is going to get. So if I'd have used a test statistic of 11 or 12 or 13, that probability will be only smaller and would still lead us to rejecting our null hypothesis. So the next thing I'm going to write is that we are going to choose to reject our null hypothesis this time. And I'm still going to write a concluding statement. So in our concluding statement here, we are still going to comment on our alternate hypothesis, and that was that the student claims to be an inspired guesser. So this time we are going to say that there is enough evidence to suggest that the student is an inspired guesser. With an E. Now, what's really important about how I've worded this, I've not just said the student is an inspired guesser, because we don't know for that for certain. This is all based on probabilities. what we've done is we've used our test statistic to see whether we think that's enough evidence to show that he's an inspired guesser or not. In my conclusion, I've said there is enough evidence to suggest that this student is an inspired guesser. And that is a really key word to use in the conclusions whenever you're using a hypothesis test. Okay? So in this second example, we looked at one where we would reject the null hypothesis. In the first one, we looked at one where we accepted the null hypothesis.